So let's define what stereocenters are, because it turns out that there's actually two different types of stereocenters, okay? So you may hear your professor refer to these as stereogenic centers, but that's just the same thing as stereocenter, okay? And like I said, the definition is any group that creates stereoisomers after swapping, okay? After swapping two atoms, okay? Or any atom that creates stereoisomers after swapping groups. So here are the two different ones. The first and most common one that we're going to talk about is called the chiral center, okay? Now I just want to make this point. A chiral center is a type of stereocenter, but they're not exactly the same thing. Because like I said, there's other types of stereocenters as well. You have to be careful with that, because a lot of times I hear students refer to these interchangeably. Like a chiral center, a stereocenter is always a chiral center. No, that's not true. There are some stereocenters that are not chiral centers, okay? So what is a chiral center? A chiral center is going to be any atom that has 4 different substituents, okay? That's it. It's a super easy definition. So if I have an atom in the middle, and it's attached to molecule atom A, atom B, atom C, atom D, that is what we call a chiral center, and it would be denoted with a star. Okay, I would use a little star to say that that is a chiral center. Why is it so special that it has 4 different groups? I'll explain that in a little bit. But that's just the only thing you need to know. If it has 4 different groups, it's a chiral center, and as you guys might have guessed, a chiral center is a predictor of chirality. So if I have a chiral center, that means that that molecule is going to be chiral. Okay? So now let's go on to the next step. The one over here is the trigonal center. A trigonal center is another type of stereocenter, but it's a little bit different. What this is, it's a double bond, so automatically that's kind of different. A double bond that's capable of making E or Z isomers. Do you guys remember what E or Z is? That's just a fancy way of saying cis or trans. Okay? E or Z is the more technically correct term because a lot of these will have more than 2 substituents, but it's the same concept where you have a double bond that can form into 2 different positions or 2 different shapes, okay? When you have that kind of double bond, that is a stereocenter, okay? But it's not chiral by itself. So these are actually achiral. So it's possible to have a stereocenter and for the molecule to be achiral if that stereocenter happens to be a trigonal center.